Good afternoon, everybody. So my name's Chewy Green and I work for a company called Hydro International. In terms of what we're presenting here today, there's quite a lot of information. So it's very hard for those of you who've already spoken to me that know me. It's really hard for me to keep to 20 minutes. So what I'm going to do is a really quick whirlwind tour of our products. And if you've got any questions or you want to speak to us, we do have a stand at number 22, or just grab me after and we can have a chat about any requirements that you've got. So just an introduction into Hydro International. So we are a water company, and the business that I look after as commercial manager is our European stormwater division. So you've got stormwater and wastewater. So stormwater is slightly different to the way that we treat wastewater, because it should be nice and clean and it should then flow nicely back into our water courses. But on the way, it could come under a bit of scrutiny in terms of pollution. So we have a selection of products that we deal with. Some of you, in terms of recognising the name Hydro, may associate it with Hydro Brakes, and that is our flagship product, which is our flow controls. In terms of what we're presenting today, it will be for high-performance stormwater treatment solutions to enhance and protect natural SuDs components. So these will be our treatment products, okay? In terms of treatment for surface water, and why do we need to treat surface runoff in terms of stormwater? When we look at the stormwater and how it falls, there's going to be quantity issues, there's going to be quality issues. So mainly due to pollution. So in terms of roads, there's going to be vehicle pollution from perhaps tyres or exhaust fumes, all that kind of thing. And this can basically get pollutions into the water course in terms of hydrocarbons, metals, all that kind of thing. So we want to be able to make sure that that water goes back into the water course as clean as possible. And in terms of what we can offer a number of solutions. In terms of how we control that and how we manage it, there are some best practices that we would follow. So first of all, we would manage surface water as close to the source as possible, so it doesn't then keep polluting until it gets to its final destination. We need to treat surface water runoff on the surface rather than underground, because it's so much easier to manage in that circumstance. And to treat water runoff to a range of pollutants. So not just the sediments, but the hydrocarbons, the relatable, the gross pollutants, all that kind of thing. And also to minimise the risk of the pollutants and re-entraining back into the system as well. Okay, so in terms of the treatment design methods that we have, I'm actually on a different slide to what I thought I was. So that's best practice. Sorry, let's go on to treatment design methods. Right, I'm up to date. Sorry about that. So in terms of the treatment design methods that we have levels of treatment. So you can go from the bottom, and then you can then have more intensive treatment. So in terms of betterment, that's for low risk areas. So where there is low risk in terms of pollution, or where you are at the end of the treatment process, so for polishing more than anything else. So in terms of your method for design in that case, it would be betterment. There are other specifications that you may have to adhere to. The simple index approach is one of them, which is outlined in the Syria guide and the SuDs manual. Okay, so it's a mitigation indices in terms of the intensity of how you would treat the pollutant and the runoff. There's also detailed risk assessments, and there's also site-specific regulations such as HURAT, which is the Highways England water risk assessment tool as well. So it could be sector-specific if that was the case. Hydro products mitigation indices. So when we talk about mitigation, we talk from 0 to 1. So 0 being the less contaminated, low risk pollution, to 1, which is really high risk, that you could cause potential problems, environmental problems. Okay, so in terms of our products and what we have, they all have a mitigation indices. So depending on what type of product that you select, the higher the mitigation indices, the better quality of treatment that you're going to get. So within hydro, we've got on this side here, we've got what is known as a downstream defender. So these are vortex separators, and these predominantly will take out sediments which have got pollutants entrained into them. We've got 3 levels of this downstream defender. So in terms of the mitigation indices, the lower level is a lower treatment product, and then you get all the way down to our advanced product, which will give you the higher mitigation indices. So it would take out more of the pollution. We've also got filter medias, and we've also got a bioretention hydro biofilter. The mitigation indices values that you can see, and they are all associated to these actual products here. So whatever your specification, you can pick which is most suitable for your actual pollutant requirement that you're designing for. So these are the 3 surface water treatment products that we have in our range: vortex separator, a fluidized bed media filter, and the biofiltration system. All different. We've got loads of information on our stand if you want to go into those in more detail. I could probably stand here for an hour talking about each of them, so that will be good. So in terms of the treatment process, we like to look at the actual particle sizes of treatment. So we look at the easier ones. The easier side of treatment would be the gross pollutants. So these are the bigger particles, and then as we go down the treatment line, we can get right down to something like 0.45 microns in terms of treating dissolved solids as well. So in terms of gross pollutants, we got physical separation. In terms of more coarse and fine solids, we've got our downstream defender, which I've just mentioned here. And then for even smaller non-soluble solids, we've got the media filtration system. And then if you want really, really intense treatment, we've got the hydro biofilter, which can do anything up to the 0.45 microns. Just a short video, is this works? I'm not quite sure if it does. No sound, but I can describe what this is doing. So this is our vortex separator. And as you can see, they're all passive units. They don't have any mechanical or electrical intervention. They just work. You put them into the ground and they just work in terms of the natural flow of the water that's coming in. This is the vortex separator. And as you can see, it's actually working for a controlled flow path. So it actually produces a vortex, which then spins around the unit. And then the sediments then come out. They get captured at the sump, and then the clean water then rises up and comes out of the outlet. In terms of what we can offer here, there's a wide range of treatment levels. So we've got different variables of this product in terms of how intense you want your treatment. There's also lots of different variables in terms of the material you want it for. So we've got concrete units, we've got plastic units, we've got different size pipes, we've got different pipe orientations, lots of variability in this product. So you can specify this and then come to us and we can then make the exact unit that you would actually want here. We've also got the enhanced media. So if you're looking to design something which is in a high polluted area for hydrocarbons, say on highways or something like that, you could have enhanced media as well, where it capture a lot more of the hydrocarbon contamination. Just going to run through this really quickly. So why do we use the downstream defense select? In terms of its small footprint, its robustness, we've got lots of different case studies that we've delivered here on major roads. So at the M25, the M1, the M6, we will all have these units on there that we've actually supplied. Just to mention the CD 528, this is the MRB, which mentions the vortex separator as an acceptable means of treating runoff on the roads, on highways as well. So there's a section in there for highways. This bit here, I could also spend an hour talking because I'd had a lot to do with the third-party validation of the performance of these units. So in terms of how we present our data and performance for these units, it all has to go through a very slick testing process. Now, you can find lots of different types of treatment units on the market, and they would all have a classified treatment flow rate. In terms of how you then interpret that flow rate is to do with the testing. So in terms of how we test, we will test to the British Water Code of Practice, which is going to be the most realistic testing for real life storms. So it will take into consideration the sediment sizes that would actually happen in a storm. Some of these products on the market will give you a treatment flow rate, but they may have different testing. So the testing would be ambiguous because they're testing with different particle sizes. So what you need to actually grasp a real storm is to have a range of particle sizes so that it will mimic an actual storm. If you test with just coarse particle sizes, which some of the units are, you're not getting a realistic treatment figure. So just to let you know, some of our mitigation values may be lower than some of the other ones on the market, but that's because we test to a different test process, and it's to do with the British Water Code of Practice and the how-to guide. So in terms of what we actually achieve for those figures there, they are realistic of a storm. We do actually test to coarser particle sizes, which will then also marry up with some of the other test methods that other people use. And in that case, we will then be able to give you a comparable test treatment flow rate, which we can be comparable to other units. We also have, because of the test method that we use, a WRC verification certification. So if you want to know more information about that and how we do that and what the parameters were for that testing and that certification, then more than happy to chat to you further on that one. Just going to run really quickly through the mitigation indices for this unit here, which is the Advanced Vortex, our default unit for the downstream Defender. So in terms of the mitigation indices and the targeted pollutants, you can see there we've got 0.5 total suspended solids, 0.4 for the metals, and 0.5 and 0.6 we can achieve the hydrocarbons. The video on here, again, I don't think you can hear the volume, but the video in the corner there is just showing you how we would actually empty these out. So in terms of maintenance, they actually have a really easy maintenance regime. So when you want to empty these units, you just send a vac tanker in and you put the vac tanker through the system, right the way through to the sump, and suck everything up. And that's how we would empty that. Really easy and really simple. This is the outflow filter. I'm just going to go really quickly through this one. Another video, no sound, so I'll just talk through it. So basically this is a media filter, and we can blend up the media to whatever you want in terms of what you're trying to treat. Okay, so the water comes in, there's uneven inlets in terms of the inlet and the outlet. So the water comes in, it rises up through the media, and then it comes out through the outlet. As I said, this media, we can specify it to sand, to CPZ, or any other blend that you want, which will then correlate to what your pollution is. Again, the maintenance of this is exactly the same as what we showed you before. You just come in through the top with the vac tanker, take out the sediments, and then also if you need to replace your filters, you can then just go and grab those filters and just replace them with new ones. In terms of this, because the flow rate is calculated through each module, so if you have a higher flow rate, the smaller module may not be enough in terms of capacity. So what we can do is build these concrete vaults where you can have a a larger number of modules if your flow rate is a lot higher than what the smaller ones can take there. There's some data there on the WRC. Again, it's WRC approved and certified. For this one, because it is a media filtration process, you've actually got higher mitigation indices. So on this one, you've got a 0.8, 0.77 and 0.7 in terms of your SIA approach in terms of the mitigation indices, but your media will also determine what those mitigation values are as well. This is our biofilter, which is referred to as a tree in the box, actually, tree in a concrete box. So this is a SuDs feature that basically can treat stormwater runoff via a live system. So this is basically a tree in a box, but not any box. It's got special engineered media, and that is the purpose of how this treats the stormwater and the pollution. So it's engineered media, so all of the innovation is in the media. And also the plant as well will take up some of the pollution as well. These are really versatile, and you can have them anywhere that you want. They're basically plug and play systems, so you drop them in and then you connect them to the pipework. They offer quite a high level of treatment compared to the others. In terms of the mitigation indices, we're going to see 0.9, 0.92, 0.8. So for really polluted areas and requirement for really high mitigation indices, we would recommend the biofilter. So in terms of maintenance, I think one of the major things that we come across is that we have a lot of these units dusted about, but do they actually get maintained? I don't know. It's one of these questions that no one can really answer. But in terms of maintenance, we've had to think about this, and we've had to think about how we can incorporate a better maintenance regime or an easier maintenance regime for these products. Okay, so we've introduced SMART, so Make It Smart, it's a smart monitoring system. Okay, so for our products, you can actually monitor, whether they whether the media is blinded, so you need to change the media, whether the vortex separator has sediment buildup and you need to empty it. So we've actually got monitoring equipment that you can actually purchase with your units to be able to monitor and alert you when your maintenance is due. Okay? So in terms of some of the data, I'll just quickly go through this. In terms of the vortex separator, this is a sediment monitor. So what it does, it's a vibration system with a sensor. So what it does, it vibrates into the sediment, and then if it's not full, then it's got full movement. So it's going to give you a tracking on your actual graph here. But when it is full and it starts to vibrate and it doesn't move, we know that it's full. So when we know it's full, it will give you a peak in terms of that graph there that you can see. And then that means that your unit needs to be emptied. So then that would send an alert to a mobile phone or a pager or whatever it is that you've got to say, please empty me. So in terms of the maintenance, then you will know that at that point, that unit then needs to be emptied. And then when it's emptied, you can then see the graph will then drop back down to normal levels. I don't know a lot about this because it's a different department to where I worked, but this was dumped on me yesterday to talk about. But we also do water level monitoring within Hydro. So we've got a separate business within Hydro, which is called DI, which is for the monitoring. So the monitoring, not of the units themselves, but this is general monitoring of rivers, okay, and flood warnings, and weather and rainfall. So in terms of what we have for that, we have a special hydro business that deals especially with that, okay? So in terms of what we can offer for that, we can offer the level monitoring. We can also offer cameras and CCTV live images, so that, if there is a problem that we see on any of the charts or any of the equipment, then we can actually log into the cameras and we can got live footage of whatever the problem is. Sometimes remotely we can go out there and we can alleviate that problem, but sometimes somebody else has to go out. So it's a totally different department. If you want to speak to me about that, I can talk to you basically about what we do, but I may have to give you some contact with some of our DI people to be able to give you some more in-depth information on that. In terms of a remote telemetry network, we've got 1,300 roundabout remote sites that we have in terms of the monitoring of rivers, floods, and all that kind of thing. So that's about enough for me. I think I might have just stuck to the 20 minutes. I do appreciate there's a lot of information there, but we are over there on stand 22 if anybody wants to discuss anything further.